Hello, my name is Kevin Pearies. I am a Senior Applications Engineer with EXFO, and today we'll be covering the setup of iOLM. The hardware I will be using today in my demonstration will be the FTB-1 Pro dual carrier with the FTB-730C OTDR iOLM module. And while I'm using this particular piece of hardware, if you are using the Max iOLM or other FTB iOLM, the interface will be very similar. I'm going to go ahead and fire up the MiniToolbox application. And here on the main interface screen, you can see the modules that are populated in my platform. So since this is a dual carrier, I have two modules. I have the FTB-730C OTDR iOLM, as well as the FTBX-945, which is an OLTS. So I'm going to go ahead and select the icon that says iOLM here in the center. This will launch the iOLM application. Now that iOLM is started, we can go through some of the interface. Up here in the top left, you see OPM. If you have the optical power meter option, this tab will be available to you. This is only available for those iOLM OTDRs that have the in-service option. Next to that is the source tab. If you want to convert your iOLM into a source, this is where you'll do it. So you'll see that we have different wavelengths as well as different modulations. So continuous for loss testing, as well as modulated signals to use with a live fiber detector or a power meter that detects that specific modulation. This next tab is the iOLM tab. This is where we will spend most of our time during this training. The next three, link view, elements, and info, we will come back to. Those are not populated until we have a trace performed. So here I am in the main iOLM screen. Over in the top left, you'll see my different fiber wavelengths as well as fiber types. So if I drop this down, you can see the different options that I have here. OS1 and OS2 are the two single mode fiber types that we test. OS1 is inside plant fiber typically, and OS2 is outside plant fiber. I'm going to go ahead and select OS2 in this demonstration. And it's always important to test 1310 and 1550, or at least a short wavelength and a long wavelength, so you can check for macro bending or cable compression in the fiber. If you have a launch fiber, loop fiber, or receive fiber, you can null those out here. So in this case, I do have a launch cable, and it is a 150 meter single mode fiber. So I'm going to go ahead and select launch fiber. And I can either manually input my distance. So right now you see it's set for 0.150 kilometers, which is 150 meters. Or I can get in here and hit the calibrate button and calibrate it off. And so what you need to do is you need to plug in your launch cable from the iOLM port and just leave it open. So I have it disconnected on the far end to measure it out. And remember to always inspect and clean your connections before you plug in any fibers. So in this case here, I'm going to go ahead and unplug the launch fiber and then do a quick calibration. And so now I have the launch cable unplugged. I'm going to go ahead and hit OK. And a measurement will be performed that nulls out or zeroes out the distance of the launch cable. So in this case, our launch cable is nulled out at 0.161 meters. So if you take into account the pigtail jumpers on either end, that's typically what we expect. If we have a loop fiber or a receive fiber, we would also plug those in and null them out individually. In this case, I am not using either one of those. Now it's time to set up the actual test itself. So over on the right side, under main menu, we have several different options. The file menu is where you manage the file, where you open existing files, save or export current ones. I'm going to go back. Identification is where you will put in your fiber ID and your location information into this particular test. It is very important to hit revert to factory settings if you're setting this up for the very first time. That way we start from a known state. So that's what we've done here. Now you go ahead and populate the information that's relevant to this test. So in this example here, I'll just put in here some basic information. I'll put my customer name, operator. So, so whatever relevant information is applicable to the test you're doing, right? In this case here, I'm going to have a fiber ID. So right now I have the company name, customer name, and my name, the operator name in there. The fiber ID here will be basically my sequentials, what fiber port I'm starting from. In this case right now, it's going to be fiber 1. I normally delete the word fiber from the value. And I also like to increase my incrementation digits. So right now you only see 1 digit here. So with incrementation highlighted, I will go down to increment down the bottom here. And you'll see the fiber ID is doing 1 digit incrementation. So I'm going to change this to 4, since we have very large fibers out there now, like the 1728 and 3456. So I'll go ahead and select that. And as far as my stopping number, I can add another digit in here as well, just in case. So I'm going to go in here and do 9999, 4 nines, there we go. Then I'll hit OK. You'll see now we have 4 digits for our incrementation. And we're going to start at fiber number 1 in this example. Now here under none, I want to change this very first none to location A. And I'm going to change this second none here to location B. And I'm going to leave this third one alone. And so under location A, I'll put in, say, a silly code of a site. And then we'll do the same thing on location B. So now let's look at what we're testing here. Right now, we're testing from LA to Burbank, fiber number 1. Got my company name, my customer name, my operator name, all the relevant information there. If I wanted to set a direction, I could do that as well here by just dropping it down. So we'll call the LA location or A location. So we'll leave this A to B. If I want to input any custom file name, I can do that as well. So I can get in here and put in a specific job ID, some sort of work order ID, whatever I want to put there. Now, if you look at the file name preview down here in the bottom, it says 0001.iolm. This doesn't tell me a lot. So I like, under the file name column here, to select what I want to include in the file name. So right now it's 001 LAX to Burbank. I normally like to put the fiber number in the back. So if I highlight fiber ID and press this down arrow, you'll see that I can push the fiber ID to the back of the file name. So now this is the file name right now. If this is what I want to run with, then I'll go ahead and leave this as it is, and then just hit OK. So you'll see here in the bottom right, next file name, and it has the identifiers that we put in there. Next, we go to test configuration. iOLM is heavily dependent on custom configurations. That's really one of the powers of the iOLM application, is the analytics or analysis portion of it. And so right now I have it set for default setup. Normally what I will do is I will create my own configuration based on the specifications that I need. You can have multiple configurations for multiple customers. And so normally what I do is I'll start with the default setup. I will duplicate this setup, then I'll give it a name. And we'll just say iOLM, whoops, off one keyboard there. iOLM general. That's what I'll call this specific configuration. Then I'll go ahead and save that. And you'll see here I have iOLM general here. Then I'm going to highlight that and select modify, and then go in here and set up my parameters. So under port, I normally leave this unspecified. This gives me the option to go between single mode and single mode live, or single mode and multi-mode, depending on the features of the hardware on your particular iOLM module. And so Opti mode, this is essentially, if you have this mode, this allows for some custom configurations for very short distance testing. And so in this case here, I'm not going to do any Opti mode. Link definition. So this is the entire span link. If you have any splitters in place, then you might want to select the splitter ratios involved. So when iOLM does its analysis, it knows to expect, that if it sees a 14 dB loss and you tell it that there's splitters in the system, it'll properly identify that 14 dB loss as, say, a 1/32 splitter. So I'm going to leave that alone. If you know the index of refraction or the backscatter, you can go ahead and input those in manually. If you don't, I recommend just leave it at default. This can always be changed later, the IOR. This will affect the distance. So if you have the white papers for that specific fiber type, you can put in the IOR or the index of refraction, right? I'm going to leave this alone. Under fiber type, there's OS1 and OS2. I also will leave this unspecified as well, and I will select it myself. So I'll leave it unspecified. And if you want to use dynamic loss budget calculation, you can. So if you have 2 connectors and 6 splices, say for a dark fiber test, so if you're splicing 864 fibers, there's a good chance that all the splices are at the same location. If that's the case, then you can put in here dynamic loss budget calculation. So you can say, I want you to give me pass-fail for loss budget based on these parameters. And in this case, I'm just going to leave this alone. I turn off the loss budget calculation in my examples. So I'll leave that alone. And this bottom one is element detection. This is kind of the delta that we set for macro bends, right? And so that's these setups here. If you have the option for custom elements, you can put in custom elements. So if you have a specific type of filter, a 1x2 tap, some complicated device with 2 or 3 merged events, you can create custom elements and assign those values to those specific locations. So element detection is very powerful if you need it. The next tab here is iOLM pass-fail thresholds. So we have some, if you have the option, you might be able to see all of these standards and certifications from TIA, ISO, IEEE, those types of organizations. This is more, we see this more on the data center side. For this example, I use custom. So in the very bottom, you see where it says custom. I'll click on that. And then over here to the right, I'll hit the arrow and expand out and create my own custom values. And so you can create your values based on OS1 and OS2 fibers. In this case here, I'm going to save some time and only do OS2. So I'm going to drop down OS2 and just leave OS1 alone. And then I can get in here and create some values here. There's that dynamic link loss budget. If you have that option, that will base your loss budget on the number of connectors and splices you specified. In this case, I'm going to turn that off. And we have, up here this fixed link loss threshold. And so you can get in here and then populate for the different wavelengths. So in this case here, for link loss, I can set the maximum of 20 dB or 30 dB. Usually I'll set this at a high value. If you're doing ultra long haul testing, you might see over 20 dB of loss, particularly at 1310. So I might get in here and just set some high value. At the same time, if I am testing, say, a fiber to the home or PON system that's engineered around a specific value, say 25 dB or 35 dB of loss, then I can put those in if I wanted to and just create a custom configuration called PON. So in this case here, I'm just going to bump up some of these to a higher value. You can determine what you want. If you want to do coefficient, so loss per kilometer, you can put those in too. 0.25 dB per kilometer at 1550, those types of things. I typically leave these off because on small sections, this often fails, right? So if you have a section that's only half a kilometer long, it often fails if there's 1 or 2 splices in there. So usually I just leave this blank. Max RL, 27 to 32 is a pretty common value. I'll go in here and put in a 28 or something like that. So this is for optical return loss. And then link length, again, this is a fairly arbitrary number depending on what you're testing. Normally, I just set this at a very high value. And so we'll set it at, say, 150 kilometers. just so I don't get a fail on distance, unless I have a distance that I want to do pass fail on, right? And so this is kind of the general setup that I do. You would do one at 1310, you do one at 1550. For the sake of this demonstration, I'm going to do them all at once, which is not typical because 1310 will typically have more loss than 1550. But in this case, just for the sake of expedience, I'm going to keep them all the same. But normally you would have different values for some of these, right? Particularly for the event loss. So down here for the splice, a typical splice loss that we see is between 0.1 and 0.3. I'm going to leave these at 0.2. And a typical connector, 0.5. Again, this will vary depending on your organization. Reflection, we see anywhere between -40 and -50 for UPC connectors, typically. Sometimes we see as high as -55, but whatever the values for your organization or this customer, you would put that value in here. And again, this is just for pass-fail thresholds. I'm going to go ahead and go with what I have here. And this last one is if you have that optical power meter option, we can read in-band power measurements, so you can set thresholds here as well. This is pretty valuable in, say, like a PON environment, where you can shoot a 1625 or 1650 in-service iOLM on live fiber and then measure the 1490 downstream at the same time. So it's a pretty cool option if you have it. In this case, I'm going to leave it alone. I'm going to go ahead and hit OK because I'm happy with this setting. And now I have this iOLM general configuration all set. All I have to do is keep it highlighted and close it. And you'll notice in the bottom left corner, we now have iOLM general. So now we'll be doing pass-fail analysis based on those thresholds that I put in there. And now with that set, I'm going to normal up my circuit. Again, remember, inspect and clean every single connection. Critically important, especially for iOLM and OTDR testing, where the launch conditions really matter. And so in this case here, I have my launch cable nulled out. I have my 2 wavelengths set. I have all my thresholds and parameters set. I have my test configuration all configured. If I want to go into user preference here, if I want to shoot a test in meters or kilometers or feet, this is where I would do it. I'm going to leave mine in kilometers. If I want to create an SOR with each iOLM trace, I can do that. So we can export a composite SOR file from the iOLM test if we want to. And the rest of these are just kind of general options where there's going to be sound when you're testing, generate report on save. I normally don't recommend this. This will generate a PDF on every single test. So that adds some time. You can always do this after the fact, right? And so you'll see the different options here. Under report, I do like to add the OTDR graph in my report. So I'll usually click that option. And so when I generate a PDF, there'll be an OTDR graph on there. And I'll go ahead and hit apply and OK. And now I'm ready to test. So I will plug into the very first fiber under test, which is port number 1. And then I'll go ahead and hit start. So basically what iOLM does is it shoots multiple pulse width at multiple wavelengths. And so it takes all of these acquisitions and kind of creates a composite. And so it's essentially, 5, 6, 7, 8, 9, 10 OTDR traces with some advanced algorithms on top of it. So it'll compare the 2 different pulse widths, see if there's any corresponding data there that it can extract from, kind of analyze, and then piece it all together into one composite trace. So you'll always see an event at 50 feet, and you'll always see an event at 50 miles. Where with an OTDR, you're only shooting 1 pulse width, so you can only see 1 resolution at a time, right? If you see something far, you most likely will not see something close up. So iOLM gets around that by taking these multiple acquisitions. And you'll see down here in the very bottom right kind of the progress. And so we're watching iOLM work in real time. So you'll see how the icons will scale and move around. That's based on the different pulse widths that are being analyzed at that specific time. So once the test is done, we'll essentially have these different icons up here. And so obviously green is the universal for pass, and then we'll also have reds for fails. In this case, we have no fails, which is what we hope to get every single time, right? But you'll see here, this very first event, you'll see the loss at 1550 and the loss at 1310 for this connector, as well as the reflection. So neg 47 is good in this particular example. And so that's what it did the pass-fail based on, right? And then we have another section of cable here. So 1.5 kilometers of fiber, another 500 meters, another 500 meters, and another 500 meters. So you can see this first one here is an APC or a UPC connector. So we expect a higher reflection. UPCs at spec are about minus 50, minus 55. We're sitting at about minus 47 here. This next one after, this is actually another UPC, and we see the values there. This particular one's an APC. APC connectors have much lower reflection, and so we see that here. Minus 74, minus 76, these are great values, right? An open UPC is minus 14.7. So as you mate the connectors, if they're UPC, it jumps up to minus 50, minus 55. If they're APC, it jumps up to minus 60, minus 65 or better. And so that's what we're seeing here. And if I'm happy with this test, I can go ahead and save it. And so I must have already done this naming convention once already, so we'll just save over what I have. And now you'll see that we have the file saved. And I can show you the Elements tab now. This shows you just the element table. So this is very useful. If for some reason you need to change an element type, so let's say it's a miscategorized APC connector, and you can drop down and change the type, which is very useful. And then under info, just kind of the general summary of what we've done. And so now I can go ahead and test the second fiber. So I'll move to port number 2 and hit start, and it'll do the same thing. And once this is complete, then it should be on fiber number 2 because we're doing auto incrementation. So you'll see already that we have a new event, or actually a fail that we didn't see before. Now we need to wait until the trace is completed before we make any determinations. Now that the trace is complete, we can look to see what iOLM found for us. Again, we still see our launch. You have the 1.5 kilometers of fiber. Now we have this new event here. See this little squiggle? This is an icon for a pinch or a macro bend cable compression in the fiber. So if I had to highlight that particular icon and go down to the bottom, you'll see that we have some analysis. Inspect the fiber in this area and search for excessive bending or cable compression. So it's essentially telling us that it found a pinch. See, at 1310, it's 0.2 dB of loss. At 1550, it's 2.0. Significant difference in attenuation between the two wavelengths. The longer the wavelength is, the more issues you're going to have with pinching. The software is intelligent enough to see that and give you some actionable items. Now that all of our testing is done, if I wanted to generate a report, say a PDF, up here in the top right, you see a little button that says report, or you can go into file and generate a report. In this case here, I'll just hit the icon. This will start up the report generation tool. And so basically this allows you to create a PDF that has all the results. And so this is kind of a universal format that any PC can open. So this is very useful if you're sending it to somebody that doesn't have the analysis software. So you can go ahead and save it to your hard drive or to your USB stick, whichever. And that report is now saved. And that's in a nutshell. That's setting up iOLM using the EXFO FTBX iOLM module. My name is Kevin Pearies. Thank you very much.